Basically, I want to go into the models of the atom real quick. So we knew that we had protons, neutrons, and electrons. I bypassed several people along the way, so count yourself lucky. But basically, the idea was, well, what's the atom look like? So Thomson came up with the plum pudding model. The plum pudding model is simply this. It's cookie dough. It's all the protons and neutrons are the dough, and then the electrons were the chocolate chips. In other words, it was just like great big hodgepodge of stuff. I'll show you one of those models on the PhET website. We'll play around with Rutherford's experiment, but Thomson was basically that protons, neutrons, and electrons were all just lumped in stuff. Rutherford, his idea was to shoot alpha particles. An alpha particle is just like a nucleus of something. It's a nucleus of an atom, of a helium actually. So he shot this alpha particle, which is a nucleus, which is pretty small. And he shot him at a piece of gold, and that gold was like freaky thin. Since the gold is freaky thin, he expected it to hit and bounce off and deflect and stuff like that because all the protons, neutrons, and everything else was kind of spread out. So he figured if his nucleus hit it, it would kind of just bounce all over the place. But what he found is that 99.9% of the alpha particles went straight through the gold, meaning they went right through like it was nothing. And a very few actually scattered. And he had screens up around, and he could count how many bounced and did that, and how many went right through. From that, from his experiment, he was able to determine these things. The nucleus is very, very small and has all the mass. And most of an atom is empty space. So the nucleus sits in the middle, the electrons fly out around it, and the nucleus has to take up a very, very small space. That was his thing. And he was from New Zealand, by the way. And you can see him looking there, looking all dapper. Up to then, no one thought that that was possible. He was pretty astonished. He discovered uranium, and he was the first guy to describe radioactivity, the idea that some elements give off these particles. He was a kook, though, because he was convinced that the sun was responsible for hitting the radioactive uranium and causing the particles to come out, meaning that the sun really was responsible for giving off the radioactivity. And the reason why he knew this was true was he could take a piece of uranium, cover it in a X-ray film, something that would show up when radioactivity hit it. And he'd set it out in the sun. And sure enough, when he set it out in the sun, the film showed little particles. So he was saying, aha, see, the sun gives off radioactivity. Well, one day it was dark, really, really cloudy, hardly any sun. And he went out and grabbed it because he was like, well, it's not going to make anything today because there's no sunlight. And lo and behold, there it was, radioactivity. So an example in science of he reached a conclusion and set up a bad experiment. But in the end, he found out the truth, that things do give off radioactive particles. For those of you wondering, where are the ladies in all this? This is Marie Curie, and this is after her husband Pierre had died. They did a lot in radioactive elements. So they discovered radium, and they've had several elements named after them, curium and ruthenium and things like that. And this is her daughter. They worked so long at it that it's almost a little sad that they did not know that radioactivity was bad for them, and they ended up dying from it. So that was not good. You guys need to know this basic thing. What's the atomic number, or the Z number? Number of protons. What's the mass number, or A number? That is the protons and the neutrons added together. AMUs tells you that it's the atomic mass unit, something we made up. That's the symbol for protons, that's the symbol for neutrons, that's the symbol for electrons. And then the other two we'll get to in another podcast.